I want you to just imagine a scenario for a second.
Yeah.
You're sitting at your desk, right?
Okay, setting the scene.
Yeah, and your mind is completely clear. You have this, like, incredibly complex, elegant architecture for a software project just mapped out perfectly in your head.
Oh, that is the best feeling in the world for a developer.
Right, it really is.
Yeah.
You know the exact design patterns you need to implement.
Yeah.
You know the precise directory structure to house it all. You're completely ready to build.
Uh-huh.
But then you hover your hands over your keyboard and your fingers physically refuse to cooperate.
Oh, man.
Yeah. The mere act of pressing a key or, clicking a mouse, it just sends this shooting debilitating pain straight up your arm.
It's a devastating bottleneck. I mean, for anyone in software engineering, your primary tool is your mind, obviously.
Exactly.
So your mind is operating at maximum capacity, but the physical hardware required to output that logic like your literal hands is fundamentally failing you.
Right.
That disconnect, it can end careers prematurely.
And that physical disconnect is really the foundation of our deep dive today. We're looking at a stack of internal design notes and architectural breakdowns for a project called ZorgStudio.
A fascinating project, by the way.
Absolutely. Specifically, we're unpacking the underlying philosophy and the mechanics of its voice control system.
Yeah, because we're not just looking at like some shiny new AI feature here.
Right. No, this is way deeper. We're examining how a severe physical limitation literally forced a complete ground-up reimagining of how humans and AI interact to write code.
The motivation here really just completely reframes the engineering approach. The creator of ZorgStudio is a 72-year-old developer named Terry.
Wow, 72.
Yeah. And for over a year, Terry has been battling this really severe case of RSI repetitive strain injury.
Ow.
And on top of that, he developed trigger finger in his right index finger. So, this isn't just some minor discomfort.
Right, it's not just a take a break and stretch.
Exactly. It means the basic act of using a mouse or typing for long stretches is genuinely agonizing.
That's awful.
So when you face that level of physical limitation, I mean, you're basically forced to look for alternatives just to keep doing your life's work.
And standard dictation tools usually come to mind first, right? But, I mean, if you've ever tried to dictate a complex JIRA ticket on your phone, the natural language processing engine doesn't understand software architecture at all.
Oh, it's terrible at it.
Like if I try to use standard talk-to-text to navigate a nested file system or write Python syntax with specific indentations and special characters, it's a complete nightmare.
Right, because standard dictation is essentially just a phonetic transcriber. It's totally blind to the structure and the logic of coding.
Just a fast typist who doesn't actually speak the language you're speaking.
Exactly. Terry needed an actual assistant, And the notes highlight a really poignant historical example here to show just how deep this problem goes. They mention Richard Stallman.
Oh, the founder of the free software movement.
Right. When Stallman was designing GCC, the GNU compiler collection, which, is arguably one of the most foundational pieces of software infrastructure in existence.
Oh, absolutely.
Well, he developed crippling RSI while building it. His wrists were feeling so badly that he actually had to hire a receptionist to sit beside him.
Wait, really? A receptionist?
Yeah, to do the physical typing while he basically dictated the code out loud.
Wow. So one of the greatest minds in computing history was reduced to, what, just reading syntax out loud to a human proxy?
Pretty much.
I can only imagine how much that disrupts your flow state. I mean, if ZorgStudio had existed back then, Stallman could have bypassed that proxy entirely, right? He could have built GCC directly just by talking to his terminal.
Yeah, he could have. And that's why voice coding, when it's applied effectively, it really isn't a novelty.
No, it's an accessibility revolution.
Exactly. It empowers aging or injured developers to maintain their professional coding output, without literally sacrificing their bodies.
Which brings us to the design choices. Because that severe physical constraint is the baseline. It dictates, every single design choice in ZorgStudio.
Right, and you see this immediately in the user interface. It demonstrates this ruthless dedication to minimal physical movement.
Yeah, so how does the UI actually reflect that?
Well, if we look at the Zorg speech voice pane, there are basically no nested menus. There are no complex settings panels, no drop-downs.
Because navigating a graphical interface requires a mouse and, well, the mouse equals pane.
Precisely. So the interaction model has to be completely stripped down. In the notes, they show how they reduce the entire recording mechanism to a single keystroke.
A single keystroke.
Yep. You just press the I key once to start recording.
Just I.
Just I. And the system automatically mutes your speaker feedback so the microphone doesn't pick up audio lips or echoes.
Oh, that's smart.
Yeah, so you speak your command and then you just press I again to stop. That is the entire physical interaction.
Wow. Minimal movement by design.
Exactly. And the moment you press stop, the back end takes over entirely. The audio is routed into Whisper Club.
Oh, right. That's the highly efficient, locally run speech-to-text engine.
Right. So Whisper transcribes your spoken words into a markdown file, and then crucially, that text is automatically pasted directly into the input line of OpenCode.
And just to clarify for anyone unfamiliar with the stack, OpenCode is essentially the command line interface where the AI agent receives its instructions, right?
Yep, that's the one.
Okay, so the user doesn't have to manually click between the transcription window and the AI prompt window. The flow is automated to just keep their hands off the mouse.
Entirely hands-off.
But looking at this architecture, my mind immediately jumps to, well, resource management.
Uh-oh, the sysadmin in you is coming out.
I mean, think about it. If you're constantly recording 10-second audio clips, generating markdown files, and feeding them to an AI all day long, a local development environment would get incredibly cluttered.
Oh, for sure.
Yeah.
Audio files eat up disk space vast.
Right. So if you're doing this all day, won't your hard drive just instantly fill up with massive, messy WAV files?
Well, in a poorly optimized system, yeah, your temporary folder would become a massive bottleneck. But ZorgStudio actually handles this with a highly efficient automated cleanup loop.
Okay, so it manages its own digital footprint locally.
Yes.
I would assume it just triggers like a batch delete script at the end of a session.
It's actually much more immediate than that. It's a self-cleaning pipeline tied directly to the execution state.
Oh, really? How does that work?
So once the AI in OpenCode receives the transcribed markdown file and successfully executes the requested action, the AI itself is programmed to delete that markdown file.
Okay.
And simultaneously, the Zorg speech subsystem deletes the original WAV audio file.
Wow. So the garbage collection happens on a per-command basis.
Exactly.
You record, it transcribes, it acts, and it immediately purges the temporary files.
Yeah.
You could literally issue 500 voice commands in an afternoon, and when you power down, there are 0 leftover temp files cluttering your disk.
Zero disk clutter. It's a completely self-cleaning pipeline.
That is such a great localized approach. But, the data pipeline is really only the first hurdle here. The much larger issue is the translation of human thought.
Oh, yeah.
Because when that clean, transcribed text hits the OpenCode input line, the AI actually has to know how to interpret it.
And this is really the crux of the problem with voice-driven development. The way humans type is fundamentally different from the way we speak.
Absolutely.
Yeah.
Like, when I'm typing a prompt to an AI agent, I'm essentially writing a structured, formal email.
Right. You take your time.
Yeah, I use precise terminology, I structure my logic sequentially. But when I'm speaking, it's much closer to, like, leaving a rambling, fragmented voicemail.
Totally. You might say, go into the config folder, the main one, and change that debug variable to true.
Right, and if an AI reads that as a literal keystroke instruction, it's going to fail because it expects formal syntax.
It will completely crash trying to parse all those filler words. So to solve this, ZorgStudio introduces a subtle but transformative technical mechanic.
Okay, what do?
When the transcribed text is pasted into OpenCode, the system doesn't just send the raw text. It invisibly prepends a metadata tag to the top of the prompt.
Oh, so they're injecting a context flag into the system prompt before the large language model ever even sees it.
Exactly.
What does the flag say?
It simply says -- voice input --
That is fascinating. By injecting that voice input header, they're explicitly modifying the weight of the LLM system prompt.
Right.
They're essentially telling the model, hey, the following text originated from a human mouth, not a keyboard.
Exactly. And that simple flag fundamentally shifts the AI's interpretation model. It instructs the AI to stop attempting literal syntax parsing and to shift into a mode of higher inferencing.
Ah, so it knows it has to fill in the gaps.
Yes. It understands that it needs to interpret conversational intent rather than treating every single word as a strict command line argument.
Which gives the AI the contextual permission to be forgiving of fragmented speech or, filler words.
Right. It closes the gap between standard dictation and an actual coding assistant.
Instead of acting like a rigid machine waiting for perfect syntax, it acts like a human colleague who understands what you meant to say, even if you stumbled over the delivery.
Exactly. It's all about intent.
But even with perfect intent recognition, There's another massive killer of the developer flow state, and that is latency.
Oh, latency is the primary reason most developers abandon voice tools. I mean, if you speak a command and then you just sit in silence for 15 seconds while a server thinks about it, your creative momentum is entirely destroyed.
And beyond just the processing lag, there's the friction of system permissions. Like normally, if I use an AI agent to modify a core system file, security protocols usually require an explicit user override.
Right, the terminal will throw up a prompt asking, "Are you sure you want to write to this file?"
Yeah, and normally you have to break your visual focus, physically reach for the keyboard, switch active panes, and then physically type Y and hit enter.
Which completely defeats the purpose of a hands-free environment.
Exactly. So how do they handle that?
Well, that permission friction is exactly what they targeted with a feature called enter key forwarding.
Enter key forwarding.
Yeah, ZorgStudio allows you to bypass the need to physically switch active windows.
So it routes the keystroke globally.
Essentially, yes. When the AI in OpenCode asks for permission to modify a file, you can stay completely focused inside the Zorg speech voice pane. You just press the enter key from where you already are, and that input is forwarded directly to the OpenCode pane in the background.
Wow. Complete hands-free approval.
Right. You never break your visual focus or physically switch contexts.
That completely removes the context switching penalty. Your eyes literally never leave the code. But wait, what about the technical latency of the file system itself?
What do you mean?
Well, if I tell the AI, open the user authentication controller, the system still has to physically locate that file across what could be hundreds of gigabytes of a project directory. Standard voice control is notorious for making you wait while the AI thinks or searches.
That's a great point, and this is where we really need to map out the underlying four-tier AI stack powering this automation.
Okay, lay it out for me.
You have the transcription layer, the intent parsing layer, the agent execution layer, and finally the file system layer.
Right.
To optimize that final file system layer, they integrated an ultra-fast local indexer called Plogate, spelled Plocate.
Oh, Plogate. Right, so instead of a standard Unix find command, which, scans the directory tree live every time you run it,
Yeah.
Plogate maintains a pre-built database of your entire file system. Right?
Exactly. It updates incrementally in the background. And to give you a sense of the performance gains here, on Terry's personal system, Plogate indexes roughly 200,000 files.
200,000.
Yeah. And when you speak a command asking to find a specific script, Plogate queries that massive database in roughly 100 milliseconds.
100 milliseconds is barely a blink. That's absurd.
It's virtually instantaneous. The four-tier stack moves so seamlessly. You speak the command, Whisper transcribes it, the LLM parses the voice intent, OpenCode triggers Plogate to grab the file path, and the action executes.
So mapping out those technical stages, how long does that entire loop take?
The notes state that the whole thing, from the moment you finish speaking to the moment you watch the requested file open on your screen, takes a total of 3 to 4 seconds.
3 to 4 seconds. That sub-second indexing makes all the difference in the world. 3 seconds keeps you locked right into the creative flow.
Exactly.
But, finding the file is only half the battle. This brings up a major architectural decision I found deeply interesting in the notes. When it's time to actually write or edit the code, ZorgStudio relies on a deep integration with Midnight Commander.
Yes.
Yes.
The classic text-based visual file manager.
Right, it's a terminal user interface, or a TUI. Through a custom script called MeGoTo, the AI can completely control the Midnight Commander work panel.
Yeah, it can navigate directories, open a file in the built-in editor, read the code, and physically write new code into the document.
Which is amazing.
Yeah.
But my question is, why build this inside a vintage terminal interface? I mean, why not integrate the AI into a modern graphical editor like VS Code or IntelliJ?
It's a fair question, but it comes back to the difference between how humans and machines interact with interfaces.
Okay, how so?
A modern GUI like VS Code relies heavily on mouse-driven events, complex window layering, and visual rendering, right?
Yeah, lots of moving parts.
So for an AI to control a GUI, it essentially has to simulate mouse clicks or use these really heavy screen reading APIs, which are notoriously brittle and prone to breaking whenever the interface updates.
I see. But a terminal interface operates entirely on standard input and output streams.
Precisely. A TUI like Midnight Commander is entirely text-based and command-driven. An AI agent doesn't need to simulate a mouse click to open a folder. It just executes a background shell script like goto, and the terminal instantly reflects the change.
So it's just infinitely more reliable for an AI to puppeteer a terminal environment than a graphical one.
Exactly. It's native to how the machine already thinks.
That makes perfect technical sense. But I have to admit, from a developer's perspective, there's some healthy paranoia
It's
here.
annoying.
Yeah. Actively allowing an AI to write and override a code base via voice commands sounds kind of terrifying.
I get that.
Like, what if the LLM hallucinate if I say, add a comment header to the main application file, like they did in main.c in the notes,
Yep.
and it misunderstands the intent and accidentally deletes a core function block? How do I stop it? If my hands are off the keyboard, how do I prevent the AI from quietly destroying the project?
That is a critical concern, and it touches on the core philosophy of the ZorgStudio architecture. The system is fundamentally not designed for blind automation. It is designed for human supervision alongside AI automation.
So how does that supervision actually manifest in the workflow?
Through visual feedback. Because the AI is puppeteering Midnight Commander directly in your terminal, you aren't just sending a prompt into a black box and hoping the output is correct.
You actually see it happening.
You see every action happen live on your screen. You watch the directory panel change. You watch the file open in the editor. You literally watch the cursor move as the new code is injected live.
Oh, so you have an instant visual feedback loop. You're watching the execution in real time.
Exactly. You are the supervisor. If you see the AI start to hallucinate or, modify the wrong block of code, you can intervene instantly.
That makes sense.
The underlying philosophy here is that the AI acts as the junior developer. It does the tedious physical labor of hunting for files and typing out boilerplate.
But you, the human, retain absolute agency over the creative direction and the final approval.
Exactly. It ensures a safe development workflow while completely removing the physical barrier of typing. You're delegating the physical toll, but retaining the intellectual control.
And because Terry is essentially building this tool in the open, iterating on it daily to solve his own accessibility issues, the project has developed a very distinct hacker ethos identity.
Oh, definitely. It has evolved from this quirky personal side project into a fully self-documenting ecosystem.
The branding evolution is a perfect example of this. I found this hilarious. Originally, Terry used a photo of Gary Oldman's character from the movie The Fifth Element.
Right. The villain, Jean-Baptiste Emmanuel Zorg. Hence, ZorgStudio.
Right. But obviously, you cannot ship a public open-source software project using a highly copyrighted image from a major Hollywood studio.
No, the legal ramifications would shut the project down immediately.
So to avoid any legal issues, Terry took an approach that perfectly mirrors the project's terminal-based aesthetic. He used ChatGPT to generate a highly stylized piece of ASCII art representing Zorg's face.
Which is brilliant because ASCII art is the native historical language of the terminal.
It really is.
It establishes a totally unique project identity without relying on external graphic assets.
It's authentic to the medium. And it led to this incredibly catchy new project slogan they use in their documentation: ZorgStudio vibe code with your face.
It perfectly captures the essence of the tool, just sitting back, watching the terminal, and speaking your software into existence.
But what is truly remarkable is the way this software is actually expanding right now. It is quite literally AI building AI.
Yeah, the development feedback loop is entirely transparent. ZorgStudio is distributed using Fossil repositories.
And Fossil, for those who might not use it, is a distributed version control system similar to Git. But it goes a step further by tracking bug reports, wikis, and project notes, all within the same repository file.
Exactly. It creates this unified, immutable ledger of the project's history. And if you look at the commit messages in the two main distribution files, -zorgstudio.fossil and zorgspeech.fossil, every single commit explicitly documents the specific AI model used for that task.
It maintains a permanent record of the AI's contributions.
It does. The logs show that DeepSeek V4 Pro was utilized for the high-level planning, architectural analysis, and intent parsing. And then it documents that DeepSeek V4 Flash was used for the actual granular implementation and rapid code generation.
So we have a scenario where Terry sits at his desk, unable to type without pain. He uses his voice to ask ZorgStudio to build a new feature for ZorgStudio.
Right.
The DeepSeek models plan the architecture and write the implementation. Terry watches the AI physically open the files in Midnight Commander, supervising the edits live on screen.
He tests the code, uses his voice to report any bugs back to the agent, and the cycle continues.
The environment is continuously expanding itself based entirely on human voice commands. It's a closed-loop system of creation.
A voice-driven, AI-assisted, self-documenting development ecosystem that operates entirely within a local terminal.
It's wild. When you step back and look at the sheer performance contrast between traditional typing and these advanced voice commands, it is staggering.
It really is.
What began as a desperate attempt by a 72-year-old developer to bypass the shooting pain in his index finger has evolved into a masterclass in human-AI collaboration.
It fundamentally proves that voice coding is no longer just a gimmick. With a 4-tier stack utilizing tools like Plogate for sub-second file indexing and metadata tagging for natural language intent, voice is now a blisteringly fast, robust interface.
And it forces us to rethink our assumptions about software engineering as a whole. For decades, we've operated under the assumption that writing code inherently requires a keyboard.
We assume that physical dexterity and typing speed are fundamental prerequisites for a career in development.
Right. But this architecture proves that code is simply logic and intent. The keyboard is just an arbitrary physical bottleneck that we've accepted as necessary.
And when you utilize AI to remove that physical bottleneck, you preserve the mind. You allow the experience and wisdom of a developer to remain active long after their hands need rest. This is a major accessibility shift for aging developers.
It really is. Which brings me to a final thought I want you, the listener, to ponder today. Think back to that opening scenario. The brilliant mind trapped by failing hands.
Yeah.
If voice-driven AI can completely decouple the physical act of typing from the intellectual act of engineering, how will this redefine the natural lifespan of our careers?
That's the real question.
Will the most profound, complex, and prolific code of the next decade be written by developers in their 70s and 80s master architects who are entirely freed from the limitations of a keyboard, simply leaning back and vibe coding with their faces?
The architecture for that future is already running in the terminal.
It really is. Thanks for taking this deep dive with us today. Go build something impossible.
This concludes the podcast. Thank you for watching. I hope you have found this podcast useful, and as always, if you have any constructive comments, I would like to read them, so drop them in the comments section below.